In this section, we're going to look at solving radical equations. A radical equation is an equation in which the variable appears in a radicand. Some examples would be the square root of x plus 3 equals 5, 4 minus the square root of 3x plus 1 equals the square root of 6 minus x. The principle of powers is the first thing we need to look at, and it says if some variable a equals variable b, then a to the n equals b to the n. Note that if you are raising both sides of an equation to an even power, this can generate results that may not be a solution of the original equation. When we raise both sides of an equation to an even power, it's essential to check the answers in the original equation. Some examples would be if x equals -3, raising both sides of the equation to the second power will produce x squared equals 9, whose solutions are x equals 3 and x equals -3. The steps to solving equations with radical terms are: 1. Isolate the radical term on one side of the equation. Use the principle of powers and solve the resulting equation. Check any possible solutions in the original equation. You would repeat this for however many radicals you need to get rid of. So practice set 1, we need to solve these equations. The first one is the square root of x minus 7 plus 3 equals 10. We're going to isolate the radical first by subtracting 3 from both sides. When we do this, we get the square root of x minus 7 is equal to 7. Now we're going to use the power principle and raise both sides to the exponent to undo the square root. So it was a square root, so we're squaring both sides. This will give me x minus 7 equals 49. And then add 7 to both sides, and we get x equals 56. Always check your solution in the original equation. 56 minus 7 plus 3 equals 10. Let's see if both sides equal. 56 minus 7 gives you 49, which under the radical will reduce or simplify to a 7 plus 3. So that does give me 10. This one checks out. Let's try part B. We have the cube root of 2x minus 5 plus 2 equals 5. We're going to subtract 2 from both sides. That gives me the cube root of 2x minus 5 is equal to 3. Now to undo the cube root, I'm going to cube both sides, or raise both sides to the third power. This gives me 2x minus 5 is equal to 27. Now add 5 to both sides. So 2x equals 32. And x equals 16. Now we'll recheck it by substituting it back into the original equation. The cubed root of 2 times 16 minus 5 plus 2 equals 5. Let's see if that's true. (32) minus 5. Well, that's just 27, so I'm just going to replace this with 27 plus 2. Does that equal 5? Well, the cubed root of 27 is 3 plus 2, and that does equal 5. So that one is also true. Let's look at part C. This has x plus 7 raised to the 1/3. So I'm going to bring that to the third power, so 3 over 1 basically, and that gives me x plus 7 equals 4 to the third. So this is equal to 64 on the right. Now we just subtract 7 from both sides, and x equals 57. Let's double check our solution. We have 57 plus 7 raised to the 1/3 equals 4. Let's see if that's right. If we add 7 to 57, we get 64 to the 1/3 equals 4. Well, the cube root of 64 is 4, so we get 4 equals 4. So that is again a true statement. Let's try D. 3 plus the square root of 5 minus x equals x. We will isolate the radical by subtracting 3 from both sides. This gives me the square root of 5 minus x equals x minus 3. Now, let's square both sides. This gives me 5 minus x is equal to x squared minus 6x plus 9. Now we need to set this equal to 0 and solve for x. Add x to both sides and subtract 5 from both sides. This will give me 0 is equal to x squared minus 5x plus 4. This will factor to a minus 4, x minus 4, and an x minus 1. My two solutions would be x equals 4 and x equals 1. And I'll check both of these now. If I substitute 4 in, I will have 3 plus the square root of 5 minus 4 equals 4. Let's see if that works. 5 minus 4 is 1, so I'll have 3 plus the square root of 1 equals 4. That one works. That is correct. Now let's try the other one. We have 3 plus the square root of 5 minus 1 equals 4. That would give me 3 plus the square root of 4 equals 4. If I substitute root 4 with 2, I'll have 3 plus 2 is 5. 5 does not equal 4, so we have to throw out the 1. X equals 1 is not a solution. Now let's take a look at the last one. We have two radicals in this example. We need to isolate a radical, which means we're going to have to bring one of those radicals to the other side. Subtract root x minus 3 from both sides. Now I get the square root of 3x minus 5 equals 2 minus the square root of x minus 3. Now we need to raise both sides to a second power. On the left side, I'll be left with 3x minus 5. On the right side, I'll have 4 minus 4 root x minus 3 plus the quantity x minus 3. And the square goes away because we're multiplying a radical to itself. We can simplify this further. 3x minus 5 is equal to 4 minus 4 square root of x minus 3 plus x minus 3. 4 minus 3 is 1. And I'm going to subtract that. I'm also going to subtract an x from both sides. Now I have 2x minus 6 equals negative 4 square root of x minus 3. We'll have to square this a second time. Four x squared minus 24x plus 36 is equal to 16 times x minus 3. Distributing, I'll have 16x minus 48. I can bring that to the other side. And we have 4x squared minus 40x plus 84 equals 0. So as you can see here, I have taken the quadratic that I found and used the quadratic formula to find the solutions. And I found two solutions. So now we have to take those two solutions and substitute them back into the original equation to see if both of them are true. And since this takes up quite a bit of room, I'm going to work this out over here. I originally had a square root of 3x minus 5 plus the square root of x minus 3 equals 2. I'm going to test 3 in this statement and see if it's true. This gives me 9 minus 5, which is 4. So the square root of 4 plus the square root of 0, which is 2. So I get 2 equals 2. That checks out. Now let's try another one. We have square root of 3 times 7 minus 5 plus the square root of 7 minus 3 equals 2. Let's see if that works. 3 times 7 is 21 minus 5 is 16. So we have the square root of 16 plus the square root of 4 equals 2. That will give me 4 plus 2 equals 2, and that is not true. So we would throw out the 7. The 7 does not work in our equation. So our one solution to this equation is 3.